Hi everyone, in today's video I would like to showcase a new framework created by Hugging Face for running AI agents, and it's called Tiny Agents. So this was initially released in April of this year. So the title here says Tiny Agents, an MCP powered agent in just 50 lines of code. So this is also where the name Tiny Agents comes from. It's just a very minimal framework, very few lines of code. In order to basically run an AI agent. And so initially, I think the first version here in April 2025 was released in JavaScript. And then a month later, they released the same thing, but in Python. And here it's 70 lines of code instead of 50, so it's still quite minimal. And I've been playing around with it, and I like it because it's great, I think, for like also educational purposes, to see like what is actually an AI agent in the most minimal way possible, what you can do with it. So it's a great way also to see like how far you can get those agents as of today, and also to see like their current limitations. It's also a great way actually to learn MCP, because Tiny Agents is really built on MCP, which is the Model Context Protocol developed by Anthropic, which is this new standard for defining how large language models are able to access tools. And so in this video, I'll just would like to run an AI agent using Tiny Agents and explain everything that is happening basically. So the nice thing also about this blog post and the one in JavaScript is they also explain how the agent is being implemented, because it's just 70 lines of code. They basically also showcase like the minimal code that was used to create an agent and to define it in the Hugging Face Hub library. So this is actually implemented in the Hugging Face Hub open source library. So this is like the Python SDK for interacting with the Hugging Face Hub. So yeah, the documentation of that can be found here. And so maybe to start off, I recently posted something on both Twitter and LinkedIn for like basically defining what is an LLM agent nowadays. So I think this kind of pseudocode tries to like summarize also how tiny agents work, but also how any of these other agentic frameworks work, because you have so many out there. You have the OpenAI Agents SDK, which is actually very, very similar. You have Agno, which is also a agentic framework, used to be called PhiData. There is Google's ADK, or Agent Development Kit, but they're all so similar. Like there's also Pydantic AI and so on, and they all are agentic frameworks, but they all share the same philosophy, the same core logic that I tried to illustrate over here, because this is basically in the most minimal way possible what an AI agent is nowadays. So it's simply a large language model, an LLM, that we run in a loop. So as you can see over here, we run a while loop in Python, and we run it as long as the large language model wants to run, basically, because we give it the full freedom to solve a certain task. In this case, the task might be given by the user input. So typically an agent is defined first of all by a system prompt, which defines how the agent should behave. Maybe also give more information about the tools that it has access to. So it is the system prompt that defines an agent as well as the tools that we give to it. And so in the case of Tiny Agents, for example, those tools come from MCP servers, which I'll also explain in a bit. And so basically what happens is we first add our system prompt to the large language model. We add the user input, which is the task that the large language model or agent needs to solve, and we equip it with certain tools. And from that moment on, the model has basically the freedom to run this loop, to start solving the task, and this happens inside this loop. So most of these agentic frameworks actually also work with a maximum number of iterations, or max turns as it is called. Like in the case of Tiny Agents, and also in the case of the OpenAI Agents SDK, I actually found this. Like if you do OpenAI Agents SDK max turns, I eventually found in the code, so they have this default max turns defined. And so if you then look into the code of it on GitHub, you will find that it has a maximum default turns of 10. So, and it's similar for tiny agents. Also there, the max turns are defaulting to 10. So it means that the loop is only run at most 10 times. And then the loop is exited. Yeah, to basically avoid that the LM would continue trying to solve the task. So we put a limit on that. And so then what happens in each turn is basically we pass the list of messages, which in the first turn only contains a system prompt and the user input. We pass the list of tools to the LLM, and we specify the tool choice equals auto parameter. So this is actually something that I took from the OpenAI function calling guide. And they have a pretty nice guide on how to do function calling with their API. And then they also explain this tool choice parameter. So by default it's auto, which means that the model itself might call 0, 1 or multiple functions. So again, the LLM has a full freedom to either call no functions, one function or multiple ones. You can also actually set the tool choice parameter to required, which means that we force the LLM to call one or more functions. And then they also have apparently a forced function option if you really want the model to call specified function. But so we set it to auto, which means that the model has the freedom to perform function calls or tool calls or not. So in the case there are some tool calls, then what happens in each of those frameworks, like tiny agents, is those tool calls are then actually executed. So for example, in the case of a weather API, let's say the model decided that it wants to call the getWeather function with parameter or argument name city equals Paris. Then we are actually going to execute that weather API by providing the city name Paris to it. And then we get, for example, the temperature from that function. And then we will provide the tool results basically back to the model in the form of messages, because each time you call the LLM you need to provide a list of messages. So then you basically not only provide the fact that the model, which is oftentimes called assistant, wanted to perform certain tool calls, but then also the tool call results basically. And then the loop continues. And so it continues to do this as long as it wants to call certain tools. And then finally, at some point, it may be satisfied with this response, and then it will just return a text response. So there won't be any tool calls anymore, and then we can just return the text response. And in this way, the model hopefully has solved its task. And you can actually easily observe this when you run a tiny agent, for example, as we will do. So maybe I can now explain a little bit. So actually, you could go into the source code of Hugging Face Hub itself as well. I think it's in the comments folder. Is there an agent? No, probably it's here. Well, actually I have the code open here, so I can look for agent.py. And so if you would look here into the code, you can actually also see that loop. So over here, this is the agent class, which inherits from the MCP client class. So an agent in tiny agents is an MCP client. So yeah, actually this also requires a little bit of knowledge about MCP. So this was introduced in November of last year by Anthropic. Model Context Protocol is like a new standard, very similar actually to how HTTP would standardize, or HTTPS would standardize the way that web clients or browsers access web servers. MCP is very similar to HTTP as standard, so a protocol, something that people agree upon, on how large language models can access tools. And so, yeah, MCP has a client-server architecture, very similar actually to web client, web server. I think this is actually nicely explained in the documentation of Anthropic. Yeah, over here. So basically, the place where your large language model lives is the MCP client. So this could be, for example, a tiny agent. it could be the Claude desktop app, it could be an IDE like Cursor, Windsurf, Visual Studio Code, and those interact with MCP servers. And so those MCP servers, some examples of that are the GitHub MCP server. For example, GitHub maintains their official MCP server, and this is basically a server that provides a set of tools to the LLM. So it exposes, each MCP server exposes a set of tools. Yeah, here you can actually find the available tool sets. So those are then collections of different tools. So you can also turn off certain tool sets and so on. And in the case of GitHub MCP server, those tools could be create issue, read issue, read the README, open a pull request, comment on a pull request, and so on, approve a pull request. So those could be the tools that the GitHub MCP server exposes. And we're actually going to use this one when running our tiny agent. So this is just a little bit important to keep in mind, that MCP is just a standard. So theoretically, you could, of course, always connect large language models with tools without using MCP. MCP just allows for some kind of standardization. So you can also find a huge list of MCP servers in a GitHub repository. So these are all official integrations maintained by companies building production-ready MCP servers. So it's just a huge list of tools that large language models, MCP clients, can now interact with in a standardized way. So it's just insane how many tools. Could be a weather API, could be a calculator, could be Confluence, could be Jira tickets, and so on. So each of those are examples of MCP servers. And so Tiny Agents quite relies on it. And so this is why the agent is an MCP client. And so that loop, that while loop that I was talking about, which I tried to include here in my pseudocode, that's actually happening over here. So while true, and it also starts with number of turns equals 0. As you can see here, we append the user input to the messages, and I think before that they append the system prompt to it, and then your loop starts. And yeah, they also do streaming inside of Tiny Agents. So then you can go here to the process single turn with tools function, which is defined in the MCP client class. And so there, basically those tools here, they come from MCP servers. So they are using the Python SDK here of MCP. Yeah, like you can see that over here from MCP import client session, because yeah, when you connect an MCP client to an MCP server, you need to start a session. It's basically some session-based management. And then all those tools from those different MCP servers are basically initialized. So what happens here is, so basically we fetch those tools from the MCP servers that the MCP client connects to. And then, as you can see over here, we already do the call to the LLM. So here we specify this tool choice equals auto. So that's also defined over here in my line over here. So there we basically are going to call the LLM API. In this case, it's the OpenAI compatible API that is being used. The OpenAI API, the chat completions API. We pass the list of messages, we pass the list of available tools from those MCP servers to the LLM API. We let the LLM, we give it the flexibility, the freedom to choose whether or not to call a certain tool. And in the case of Tiny Agents, it's also being streamed, so the response is being streamed back. And then here that stream is being read. And from that stream, so those could involve just text tokens from the LLM response, but it could also involve certain tool calls. That happens over here. So if it finds certain tool calls, then we basically are going to add those to a dictionary, final tool calls. So those are yeah, all the tools that the model wants to call based on the current request. So we do that based on, so we provide a index as key, and then we will provide both the name of the tool to call as well as the arguments with which to call that tool as values in that dictionary. And then yeah, it might happen that we already are exiting the loop over here. For example, if there are no tools to be called, so if length of the final tool calls is 0, so that actually means here there are no tool calls, so we end up here, so we just will return the text response. So that's what's happening here. So we are basically returning that response back to the user, so the loop ends. Otherwise, if there are certain tool calls, and that's what's happening over here, then we basically have the execute tools logic. So that happens over here. So here what we're doing is basically we append them to the list of messages. So that's actually what's happening over here. So we add basically the fact that the model, which is the assistant, wants to call certain tools. We add that to the list of messages. And then here I think the actual tools are being called. So that happens over here. Yeah, so in this line specifically, and this is again thanks to the MCP standardization, we can easily just do session.call tool with the name of the function and the function arguments. So then those tools, those functions are actually being executed, and we fetch the results from that. So here, and then we also format it into the format that the OpenAI API expects. And then, as you can see, we append those tool results to the messages, and then the loop continues. So this is basically in a very minimal way explained how tiny agents, but also any of these other agentic frameworks like Agno, which is a popular one, but also the OpenAI Agents SDK and so on work. Of course, they're like, I don't think they integrate with MCP at such a high level as in Tiny Agents, because Tiny Agents only works with MCP servers. I think these other frameworks like OpenAI Agents SDK, they also support MCP, as you can see over here, but I think it's optional. You can of course just provide those tools to the LLM without having them come from MCP servers. And so yeah, this is just in a nutshell explained how Tiny Agents works. And so yeah, maybe here already a short demo of how it then works when you run such an agent. So as I said, it's a very minimalistic framework. It's basically just this ID. So we just let the LLM run in a loop. It has access to certain tools, and we let it do its thing. So in this case, for example, here when you spin up a tiny agent, yeah, it first will indicate. So you need to run the tiny agents run comment, and then the name of a certain tiny agent, and this is actually specified in a Hugging Face dataset. So if you would go here to Hugging Face and you go to this dataset, here some demo agents are being shown. So here in this case, let me go back here to the demo. She's running the Selena H/web browser demo. So let's go here to this one. So, and over here you can actually see how you can specify or define an agent in the Tiny Agents framework. So you first need to define the system prompt in a prompt.md in a markdown file. In this case, as you can see, the system prompt is pretty minimal. It just says, you are an agent, please keep going until the user's query is completely resolved before ending your turn and yielding back to the user. Only terminate your turn when you are sure that the problem is solved, or if you need more info from the user. Yeah, actually something that I also noticed when going into the source code of Tiny Agents is that this loop can also end in two other possible ways, namely if the model calls the task completed tool. In this case, the loop will also exit, and it will also exit in case the model calls the refer to human tool. So in case it needs like some additional input from the user, basically Tiny Agents will also append that tool, the refer to human tool, as well as the task completed tool to the model, which might also exit the loop. All right, so yeah, so you basically need to define a system prompt first of all, and yeah, one thing that might be important here is defining or saying please keep going until the user's query is completely resolved, to make sure that it really continues calling those tools in order to solve a certain task and not just return a text response at some point. And then besides that, you need to define a JSON configuration, which just defines which LLM to use, and in this case from which provider, because Tiny Agents is powered by Hugging Face inference providers, which is a new solution offered by Hugging Face. It's basically a abstraction on top of a lot of API providers, very simple, similar to OpenAI or Anthropic or Google. So here Hugging Face partners with a lot of inference providers, including Replicate, Together AI, Sambanova, and so on. You can actually, for example, nowadays, and this is also the model that I'm going to be using in this demo, is this new Kimi K2 model from Moonshot AI, which is a Chinese startup. They released a super impressive new model that is actually optimized for agentic intelligence. So it's really great at tool calling. It has been trained explicitly for it. It's also great at coding and so on. So we're gonna definitely be using this one. And so it's powered, Tiny Agents is powered by inference providers. So here you can see which model providers support hosting this Kimi K2 model. And so we will be using the Grok provider. So as you can see, you can actually also call the Kimi K2 model with the OpenAI compatible API, and everything will be built through your Hugging Face account, which is quite handy. And here you can actually already directly interact with the model through inference providers. Alright, and so as I was saying, so you need to specify which model to use. So we're gonna not use the Quen 2.5 72 billion model, because nowadays I think Kimi K2 Instruct here will be the best one for tool calling. And then you also need to specify your MCP servers, so the ones you want to connect. Basically this will define which tools the model will have access to. In this case, as you can see, only a single MCP server has been defined, which is the Playwright MCP server. So this is one from Microsoft. And what this basically allows to do is it allows large language models to access web browsers and fetch content from certain web pages. So it basically allows LLMs to browse the web. And that's also happening over here when you run the agent. So when you run it, the first thing it does is basically listing all the tools that it has been equipped with. So in the case of Playwright, as you can see, the model then has access to tools like browser navigate, so it can navigate to a certain web page, it can navigate back from another page, it can navigate forward, it can save a PDF, it can take a screenshot. So all these kind of tools are now accessible to that agent. And then you can just specify a user input. So this is the user input, so referring back to our figure over here. So the system prompt is what comes from here. So if we go back here, this is the system prompt. So that's the first thing that's going to be appended to the messages. And then the user input is what the user here inputs as a task for the agent to run. So in this case, it's do a web search for Hugging Face inference providers on Brave Search and open the first result, and then give me a list of the inference providers supported on Hugging Face. So that's the user input. And then as you can see, let's maybe pause a little bit. So then the loop starts basically, because then we're entering this loop over here. And then the first call basically happens. So here it says, to accomplish this, I'll follow these steps. Navigate to the Brave Search. So it performs some reasoning first, and then as you can see, it starts calling the first tool. In this case, it calls the browser navigate tool from the Playwright MCP server with as argument URL equals search.brave.com, because user asked to go to Brave Search and use that one. So then basically what happens is we're gonna execute that tool. So then the browser navigate tool from the Playwright MCP server is actually going to be executed. So that means that an actual web browser is going to be opened and we're going to the Brave Search web page. Okay, then it's on the Brave Search homepage. Now it will perform a search. So then again it calls a tool. So again, then we basically run the loop for a second time. Now it calls the browser type tool, and then it specifies text-based search with text equals Hugging Face inference provider. So this basically allows, it's a tool basically that allows the model to enter text in a box. So then it enters that. Okay, and then I think, yeah, it basically receives, that's the tool call result. So it receives the result from that search, and then it performs. So then we are entering the loop a third time, because now it has fetched those search results, and it says, okay, the search results indicate that the first link is likely to contain the information we need about Hugging Face inference providers. Let's open this link and capture an accessibility snapshot. Okay, so then it calls again one of the tools of the Playwright MCP server. In this case, it calls the browser click tool, because it wants to click on something, namely, and then also needs to specify which element to click with, because each tool always expects one or multiple arguments. So it decided to click on the first link, and then again it will fetch some results. So those are the tool call results. So that's execute tools line over here. It fetches those results, and then it performs some more reasoning. Okay, based on the snapshot of the Hugging Face inference providers documentation page, I can now see the list of the supported inference providers. Here is the list. So then I think it will complete. I don't think it will, because now it has already found the answer. Yeah, so then the loop basically ends, because as you can see, it hasn't called any other tools anymore. It just exits the loop over here because it hasn't, there were no any tool calls anymore. So then we will just return the text response. So here it's provided the list of all the supported Hugging Face inference providers, and then it asks, would you like any further information or assistance? If not, I'll mark the task as complete. So that's basically how it works. And this is just a great way for you to play around with these AI agents, play around with MCP servers, their tools, and so on. Yeah, one thing that Tiny Agent does not support so far is you cannot turn off certain tools of certain MCP servers. That's kind of a disadvantage, because sometimes you have MCP servers that have like 50 different tools, and there's no easy way so far to disable, let's say, 20 of them, because LLMs are also a bit sensitive to the amount of tools you provide to them. In this case, for example, with the Playwright MCP server, I think there are quite a lot of tools, yeah, that you can see over here. So browser click, browser close, and so on. And actually, the fewer amount of tools you provide to the LLM, the better, the more reliable it will get, because LLMs are great, they are powerful, but they might easily mess up with the amount of tools you provide to them. So ideally, and I think I'm gonna actually make a contribution on that, to make sure that we will be able to disable certain tools or tool sets from MCP servers, because right now, yeah, it just loads all the tools by default from any MCP server. However, for the GitHub MCP server, there is like this GitHub toolsets thing, where you can already specify only certain sets of tools that you want. For example, if you only want tools that are related to GitHub issues and pull requests, you could only include those two in the GitHub toolsets parameter of the GitHub MCP server. Okay, so that's Tiny Agents in a nutshell. The final thing I just want to do now is run our own agent. So I was actually playing around with this a little bit, and I can showcase my system prompt. It's quite a long system prompt, as you can see over here, but I'm pretty sure, and this is actually also how things like the cursor agent, for example, it works in the exact same way. It's powered by the Claude for Sonnet or any of the other available LLMs, but it also runs inside this loop with a certain maximum of iterations. And it also has a pretty giant system prompt. There was actually an interesting post on this, 9 lessons learned from Cursor's system prompt or something like that. Yeah, and you will see that it's actually quite extensive. And so this is also why my system prompt is quite extensive, because in this case, what I wanted to create here is an AI agent. Yeah, that is part of the Hugging Face team, let's say. And basically what it needs to do is it needs to, for a given new research paper, because on Hugging Face we now have huggingface.com/papers, you can find the top trending research papers every day over here. People can also upvote them. The goal actually of Hugging Face paper pages is that authors upload and link their models, datasets, and demos in the form of a Hugging Face page to it, to basically improve the accessibility and discoverability of their Hugging Face models, datasets, and so on. And so I was interested to see here whether we could have an AI agent that can just figure out, based on a given research paper on Hugging Face, whether it's able to find whether there are any new artifacts, whether there are any new pre-trained checkpoints, for example, or any new datasets. And if there are, it needs to also provide the hosting URL. So are they already hosted on Hugging Face or not? Because oftentimes when researchers publish their work, they don't always host it on Hugging Face. So this is why I'm interested to see, for a given research paper, is an AI agent able to basically go through it as I would do. So I would probably very quickly read the abstract, maybe find the GitHub URL, then read the GitHub README, check whether there are any new models or datasets, and if there are, check whether they are already hosted on Hugging Face, whether they are linked to the paper page, and so on. And if not, it should actually create a GitHub issue to reach out to the authors saying like, hey, you can actually host your model on Hugging Face for free. Here are some guides to do that. And then it could include some links like the uploading models guide from Hugging Face and so on. So this is the use case that I wanted to check. I'm not going to go into the full details of what it can all do. I just specify some of the logic that I also apply myself when going through a paper and checking whether it's hosted on Hugging Face or not. And then besides that, we have our configuration. So here, as you can see, already specified that I want to try the Kimi K2 instruct model with the Grok provider. So I could also provide here Together.ai or Novita, which are the other inference providers, which you can find over here. But I'm going to use Grok here because it's also known for being super fast. And then, so these are the MCP servers that I connected to it. So I also use this Playwright MCP server because this will allow the agent to browse the web. And if it, for example, wants to read the Hugging Face paper page, it can do so using the tools from the Playwright MCP server. And then I also connected to the GitHub MCP server. So that's done over here. I'm not going to go into the full details of how to run this MCP server, but one thing that is important here, I'm going to check if my Docker is running locally, because that's needed for running this GitHub MCP server locally, because we're running all these MCP servers locally on our own laptop using the standard I/O protocol or communication protocol. And as you can see here, well, actually for GitHub toolsets, I'm also going to let it open issues. It doesn't need to create pull requests. And then you also need to provide the GitHub personal access token so that it can actually create GitHub issues in your name and fetch content from GitHub. And then the final MCP server that I also connected over here is the Hugging Face MCP server. This is also something that is pretty new, but now there is a official Hugging Face MCP server. You can access it over here. It's quite cool. So these are the tools that you can enable, and in this case it's actually also running locally using the standard I/O communication protocol. So in this case you need to provide your Hugging Face token. To be honest, I haven't checked whether in my system prompt I also ask it to create GitHub issues. Because I think in this case, the only thing I asked it to do so far is just basically return a JSON containing the GitHub URL of the paper, the project page URL, whether there are any new model checkpoints, new datasets, and so on. So I haven't really asked it so far to open GitHub issues in my name, but that could be a next step. So I'm gonna try this and run this locally, assuming that I have to do Control-C probably. Okay. So what I'm going to do here is I'm going to take a paper. Maybe it should be interesting to take one that actually has some models that are maybe not on Hugging Face yet. Let's see whether this one has it. So this is a paper. It provides a script. Anyway, I'm just gonna let it do its thing over here. So I'm gonna do tiny agents run, and then you need to specify either the name of a folder. So in this case, my folder is called agent. Then it says some initial inputs are required by the agent. Please provide a value or leave empty. Yeah, this is actually coming from the inputs field. So those are for those secrets, those passwords or tokens that you need to provide. In this case, I'm using the GitHub MCP server, so I need to provide my GitHub personal access token. And I'm using the Hugging Face MCP server. Yeah, you might be interested actually in which tools the Hugging Face MCP server provides. So it will allow the model to search for different models. It will allow it to search for datasets, get details from a certain model, get details from a certain dataset, perform semantic search on huggingface.com/papers, and also search the documentation of Hugging Face. But yeah, by default it loads those from an environment variable, which is pretty nice. But there is an issue. Okay, no worries. I'm just gonna quickly set those environment variables and then I'll come back to you. Alright, we are back. So yeah, some things that I had to fix here was, first of all, I had to start my Docker desktop app that wasn't running. Secondly, there was a space over here for my GitHub toolsets. There cannot be any space over here. Thanks cursor as well for fixing that. So then let's run again tiny agents run agent. Yeah, so by default it's loading those from an environment variable. And then it's actually loading those tools from those MCP servers. So as you can see over here, it has loaded the agent with 58 different tools, so that's quite a lot. Which is why it would be nice to like disable certain tools, because it doesn't need tools like fork repository, delete file, and so on. So as you can see here, it loads those tools from the GitHub MCP server, as well as the Playwright MCP server. So all the tools here related to browser are the tools coming from the Playwright MCP server. And then finally, those are the tools from the Hugging Face MCP server. So here actually, yeah, maybe unrelated to the system prompt, I can just also ask it things like, can you give me some more details about this model? And then I can just ask it to go here to, for example, this top trending model. And then it should be able to call the model details tool from the Hugging Face MCP server. So let's see. So here in this case, indeed, it calls the model details tool with model ID Moonshot AI, and then it gets the tool call results. So it gets basically, I think, the content of the model card, so the README of that model. And then it says, based on the information I found, here are the key details about this model. So yeah, that's quite nice. And this also showcases how good this new Kimi model is. Like, it can know, based on the list of 58 different tools, that it needs to call the model details tool. But okay, I'm gonna run it for the task that we designed it for, which is finding new artifacts for Hugging Face papers. So I'm gonna go back here to this paper. So let's ask it, please find new artifacts, if any, for this paper. And then the loop starts. So let's see what happens. It says, okay, so it immediately already starts using the Playwright MCP servers tool, namely the browser navigate tool, to see, I can see the paper is blah blah, and oh, okay, it seems to do already more stuff. Yeah, it goes actually to the GitHub URL. That's quite nice. Oh, and now it starts reading the project page URL. That's quite nice, because it needs to find any new models or datasets. Then it says, now let me check if there are any specific model checkpoints or dataset mentioned in the repository. Let me check the requirements.txt file. So then it uses the get file contents tool that's from the GitHub MCP server, I think. So it reads the requirements.txt file. That's pretty interesting. Then it again uses the get file contents tool from the GitHub MCP server. So it seems that it's going through the GitHub README basically and the GitHub repo to read various files. That's quite interesting. So it seems to read through the inference v1.yaml file and so on. and it performs some more reasoning. So it's literally going through like the files of the GitHub readme. Sorry, and the GitHub repository to find. Okay, now it's. I think it also reads some Python file. And yeah, I'm afraid this is mostly because we have done quite a lot of requests. Okay, but so yeah, what I learned from that is that it first found the GitHub, and then it basically starts reading, for example, the requirements.txt file. It starts reading certain scripts to figure out whether this. This is maybe something I could do myself as well when I try to figure out whether a new paper also releases new models. But yeah, then there was some issue encountered with the Hugging Face inference API or Hugging Face inference providers. Maybe let's try another paper over here. Yeah, this one probably doesn't introduce any new models. This one does. So let's maybe try this one. Please find any new artifacts for this paper. So I'm curious what it's gonna do now. So we're starting the loop. In this case, it calls the paper search tool. So that's interesting because it wants to read the content from that paper, like the abstract. Okay, now it's doing another tool call. It gets a lot of information, I think, from GitHub, and then it says MCP tool call failed with error message, failed to search repositories. I hope my GitHub personal access token is set correctly, but I think so, given that. Okay, now it says great, I found a repository. So it seems to again read. So it seems that Kimi K2 really likes to go through files of GitHub repositories whenever it finds them, in order to find any new models or datasets. And then it reads again another file. Let's also check. Blah, blah. Yeah, it starts reading through some folders. Okay, so yeah, in this case again it seemed to have failed with some 503 error message. Maybe we can try a different provider over here instead of Grok. Let's try it together. Let's see whether it does something similar. I'm gonna ask it like, there's no need to go through each of the GitHub files besides the README. Maybe this is also something I could specify in the system prompt. In this case, it uses the browser navigate tool from the Playwright MCP server, and it starts reading the README as I asked it to do, basically. So yeah, this of course allows for some tweaking. Like I haven't tweaked the system prompt at all myself yet. Okay, then it performs some reasoning, and then I think it's gonna exit the loop because it seems to generate the JSON that I asked it to generate. So in this case, it found the GitHub URL from that paper. So let's see if this works. Nope. Seems to be hallucinated. This is the correct one. Let's see. This is the correct one, and this is what I think it messed up with the. No. Wait. Let's see what are the differences. Okay, it seems to have created a different username. That's interesting. And then the project page is also completely hallucinated. Memories.ai, but I'm not sure, does this come from this paper? Ah, it does, okay. So that's actually the project page, that's correct. And then for new model checkpoints, it finds them. So this is the model. So that's correct too. And it's, also ask it not only to provide the name of the model, but also the hosting URL and the pipeline tags. In this case, it says video text to text. So it's a video large language model basically. And then it does the same thing for the dataset. And it finds that this paper introduces new artifacts. So that's quite nice. This is exactly what I wanted. So there's still a mistake here in the GitHub URL. So there seems to be like some weird hallucination going on over there. But other than that, it went pretty fine. Of course, now my next step would probably be to tweak the system prompt, try it on as many papers as possible to see whether it's able to correctly parse the papers. And then theoretically, I could also ask it in the system prompt to also open GitHub issues to reach out to authors in case their models or datasets are introduced in the paper but are not yet released on Hugging Face. Alright, so this was just a short introduction to tiny agents, to basically how agents work in the most minimal way possible. I hope you also learned something about MCP, the Model Context Protocol introduced by Anthropic. And yeah, I hope you learned something. See you in the next video. Bye-bye.